Right. So all of my pre-calc classes were kind of ended in different spots yesterday, so you might have to remind me. Did we get to the point where we had this equation? That's when the bell rang. Okay, so we got to answer a few questions about this. So yesterday we spent quite a bit of time, and we're going to do another example today, typing in this data into our calculator. We then viewed the scatter plot on the calculator to see what shape of the graph, what it looked like. Was it straight? Was it kind of curved? And based off of the shape of the graph, you can determine which type of an equation would be the best fit. Okay, I think we decided yesterday it looked pretty straight, so we would use a line equation. So using the calculator, we used linear regression, and it popped up with these two numbers for the m and the b that we were able to put into our slope-intercept form equation. So this is the line of best fit. What we're going to do today is see how good this line is, okay, because this is an estimate. This line goes through or gets close to as many of these points as possible. So do me a favor, go ahead and turn on your calculator. Not sure if the data is already in your calculator, but let's go ahead and check it. Okay, we're going to see how close this equation is to those data points. Okay, how can we check to see if the data is in the calculator? Where did we go to type in the data? Remember, go ahead, Emily.
Stat.
The stat button. Yep, right next to the arrow keys. And we're going to select edit. Okay, immediately hit enter. And notice how the data is all in there. Okay, so if your data is not in there, you need to go ahead and type that in right now. All right. After we typed in the data, we took a look at the scatter plot. That is where the stat plot button is in the top left-hand corner, but do you see how it's blue? It means you got to hit the blue button first. And we want to make sure that it's on. That way it plots the points. Okay? If yours is off, you're going to have to change it. Okay? Anything for the office this morning? Good morning. We don't have anything today. Okay? Have a good day. Have a great day. Yep. All right. Is everyone's stat plot on? Good to go? Okay. Let's not get ahead of ourselves just yet. Okay, we can't graph it yet. We have to go to the window button and make sure that the window we have set is appropriate for the data that we have. Now, yesterday we used the data table to help us with these numbers. Notice how the lowest x value was 5, but we went a little lower than that, just to make sure we could see it. And the highest x value was 34. And we went a little higher than that so we could see it. Okay, same thing with the y's. Okay, so data's in the table, stat plot is on, and window looks good. Let's go ahead and hit graph. We should be able to see all those data points. Does anybody have some type of line or curve going through theirs? Do we need help back there? Yeah? Okay. Yours too? Yours too? All right, so you have
Yeah, I drank some when I came in.
So All right. So we have our data in. We have the little dots on our graph. Perfect. Now what we're going to do is we're going to type in this equation we have, and it should go through some of the points. Maybe it's really close to some of the points. So we're going to go to the y equals button and go ahead and type in the equation from yesterday. 11.731 x plus 193.852. All right, go ahead and hit graph. Pretty good fit, right? Really close. Okay, for the dots that actually are black, you see how that one is kind of dark right there? That the line's actually going through that point, so that means it's very, very accurate. But we're as close as we can to the other points as possible. So this is the line of best fit. So what this equation gives us is a way to predict data. Okay, we might be able to figure out certain things based off of this equation. They might not be accurate, because notice how some of these data points are slightly off from the equation, which means if you use the equation to help you answer questions, your answers might be slightly off from the actual, but it's a way to predict or estimate information. So that's what we're going to do in these two questions down here. So the first one says, predict the calories of the grilled cheese burger that has 79 grams of fat. So if you take a look at your data table, clearly 79 is not a part of that, right? Because the highest we had was 34. But now that we have this equation, we could use it to predict this information. Okay, if we had this grilled cheeseburger, how many total calories might it have? Okay, it's going to be an estimate because it's a prediction. Okay, so how might we use that equation to help us answer that question? What do you think, Tori? Plug 79 in for x. Yep, your total fat were your x values and calories were y's. So let's go ahead and plug in the 79 for the x. All right, so on your calculator, for you to get rid of your little scatter plot screen, do you see the quit button above the mode? Okay, it's blue. So you gotta hit the second button first. Okay, the second quit always gets you out of that graphing screen or any menu type screen. It'll bring you back to the main calculator screen. So you can go ahead and type that in. So we would approximate or predict that if we had this grilled cheeseburger that had 79 grams of fat, it would be roughly around 1,120 calories, roughly. Could be a little more, could be a little less, but this is our prediction based off of that line of best fit. Okay? What about the second one? Predict the fat grams of an 800 calorie sandwich. Good, Ashley? Plug it in for y. Right now we have a calorie value.
Excuse me, interruption. At this time, I need all seniors to report to the auditorium for your class meeting. All seniors to the auditorium, please. Thank you.
Have fun. Don't enjoy the air conditioning too much. All right, so now that we plugged in the calorie, our answer should represent a fat gram. How might you want to solve for x? You could do two different things. Wait, go ahead. There we go. So this one would be easily solvable using some algebra. Notice how there's only one variable in there, okay, one x, so you could start moving some things to the other side. In some of the examples we saw so far this year, if we plugged something on the left-hand side, couldn't we graph possibly both of these and find the intersection point? Remember doing that? Okay, that method is very, very nice when you have multiple variables, multiple x's, but since we only have one in this case, maybe algebra would be a little bit quicker. So let's go ahead and we can subtract over the 193, divide the 11.73. If you had an 800 calorie sandwich, approximately how much fat would be in it? Can we find that? Good, Marie? 51.7, okay, if you round. 51.671, something around there. That's good. Can we get that value? Good. Okay, so again, regression is the process of figuring out the equation that best fits a data table. And once you can figure out that equation, the possibilities are endless as to the questions or the predictions you can answer or make. Okay, anything you wanted to know about this scenario, you could use that equation to help you answer. Okay, so we're going to check out another one on the back. All right. The table below lists the number of Americans in thousands, okay, sometimes we've got to be careful with this, in thousands, who are expected to be over 100 years old for selected years. So how you read this, in 1994, there were 50,000 Americans, okay, not just 50. You got to be careful with how they organize their table. So the first question is, find a friendly window to view the scatter plot, okay. We'll get to using our calculator in a second, but we don't really need it to answer this question because we can just look at the data table to figure out our friendly window. So in our window on the calculator, we normally have x min, x max, and then x scale, what you want to count by. And then the same thing for the y's. So the way this table is organized, it looks like the year is going to represent an x value and the people are going to represent a y value. So what do you want to let the lowest x be? Emery? You could, okay, so our starting year is 1994. Typically we go a little bit lower than that or before that, just to make sure we could see it. Now this is what's a little kind of tricky, okay? When you see 1994, to us, okay, people, that's a year value, right? But when you see 1994, what do you think your calculator sees or understands that to be? Good, Marie? It's 1,994. Okay, that's a very large x value, isn't it? 1,994. So in terms of years, it might be in our best interest, instead of working with numbers in the thousands, let's make them smaller. Okay, so if this is the first year in our table, let's let that be the starting year. Okay, year 0. What would then 1996 look like? If 1994 was our starting year, good, Marie? Okay, it could be 1 because 2, right? Okay, so 2 because it's 2 years after the starting value. So if we continue that pattern, we would have 4, 6, 8, and 12. So what we're doing is we're making it a little bit easier on our calculator. Instead of typing in those thousands numbers, we're going to type in 0 through 12, counting by 2s. Yes? Did I miss 10? I'm sorry. Got a little ahead of myself. Okay, 0 through 10. So we got to be careful with years. So let's now think about a friendly window. X min. Go ahead, Ashton. You could do 0. Okay, if you wanted to go a little bit less than that, you could go negative. That's okay. X max. Good, Marie? You could do 10. You could do 12. You could go a little bit more. Okay, it's completely up to you. And I think it would make sense for us to possibly count by 2s, because that's what the data table is counting by. All right, what about the Y's, or the people? The lowest Y value is 50. Maybe you want to go a little bit lower than that. Go ahead, Maddie. 45, sure. Highest is 110. Go ahead, Hannah. You could go 115. And what do you want to count by? Go ahead, Marie. 5s, sure. Okay, so without using our calculator just yet, maybe this is an appropriate window we could use once the calculator is necessary. Okay, so let's take a look at 2. Determine the function that best represents your data. Okay, so we need to determine if we were to plot these points, would we want a line? Okay, would our data look straight? Would we need a curve because our data is a little bended? Okay, we have to view the scatter plot. So in order to do that on our calculator, we have to first type in our data. Okay, I forget who reminded us before. Was it you, Ashlyn, that said stat at the beginning? No? I'm sorry. I forget. Someone said we hit the, oh, I think it was Emily. Okay, so you hit the stat button and then enter. The data from the last problem's in there, but we want to clear that out. Do we remember how to clear out the numbers? Kind of quickly? Yeah. Yep, go to the very top, hit clear, arrow back down, the whole column will go away. Okay, so let's go ahead and type in our numbers. We're not going to type in the years. We're going to type in our abbreviations for the years, the 0, the 2, and so on. Next comes the people. All right. Now we already know the stat plot is on because we used that in the last example. Let's go ahead and change the window. That way we can see these data points appropriately, and we already figured out what that would be. All right. So go ahead and hit graph. What do you think? What type of an equation would be the best choice? Does that data look straight? Does it look curved? What do you think we could use? Good, Marie? It's slightly curving. Okay, so a straight line obviously might work a little bit because we can get really close to some of the points, but if you had a curved line, you'd be able to get closer to many more points. Okay, so for number 2, it says determine the function that best represents the data. Do we remember the name of the function that's curved? Kind of looks like a U. U's are curved. Yeah, quadratic. Okay, so we're going to say quadratic because, notice how it said justify your answer. Okay, quadratic because the scatter plot was curved. All right, so now that we know the type of equation we want to let the calculator figure that out for us. How can we exit out of our graphing screen? Good. Second quit. Okay, so we use the scatter plot with what we need it to do. We're now going to find the equation. So we're going to go back to the stat button, instead of hitting enter like we did before to type in the numbers, we're going to scroll over to Calc, and this is where all the options are for your different types of equations. Now we said it's quadratic would be the best fit, so which option do you think we'll choose? Good, Marie? 5, yep, quad reg, it's abbreviated. Okay, so go ahead and hit enter. If this screen pops up, you just keep hitting enter till you get down to calculate. If that screen doesn't pop up and you just have like a single line at the top of your calculator, just hit enter and those numbers should pop up as well. Okay? Can we get those same numbers? We all should have the same numbers because we all typed in the same data, right? Okay, so at the top of the screen, it's giving you the standard form equation for a quadratic, and then it's telling you what the different A, B, and C coefficients are. So we're going to take those numbers and plug them in into the appropriate spots. Maybe we'll go to 3 decimal places just to be kind of accurate. Okay, so our equation, we'd have 0.402 x squared plus 2.039x plus 50.071. We doing okay? All right, so now that we have this equation, okay, let's go and see how accurate or how good it actually is. Okay, let's see how close it can get to some of those data points. So now that we have the equation, let's go to y equals. We'll clear out the line from the last example, and let's go ahead and type in our new curve. Alright, once you type it in, you can hit graph. And that looks like it's pretty darn good, right? I think there's about 3 or 4 dots that are filled in. Means it goes through them exactly. Okay, so this is a very, very good, very, very accurate equation. That means if we use the equation to help us answer any questions, our answers are going to be very, very close to the actual answers, like the real life numbers. Okay, so let's go ahead and take a look at 4. Predict the number of 100-year-old Americans in 2010. Notice how our table only goes to 2004, so we're predicting some information here. How might we use the equation to help us answer that question? Good, Ashton? Plug in for x. Okay, so the question is, what do we plug in for x? Good, Marie? 16. How'd you get 16? Right, okay, so since we changed what the x's actually represented, we now have to figure out how many years after 1994 is 2010. Okay, so that would be 16. So you're not actually plugging in 2010 anymore, you're plugging in how many years after that beginning date, which would be 16. So let's go ahead and plug in 16 for all those x's. Okay, again, you might have to second quit out of your graphing screen to plug in that number. We get 185? Around that? Okay. Now, is this 185 people? What do you think, Marie? It's 185,000. So if you were to write this in terms of thousands, we'd have 185,607 people. I know some of you might see that decimal and think, well, you can't have 0.607 of a person. And I know that makes sense, okay? But in this case, we're talking about thousands of people. So you might have to do a little movement of the decimal. Okay? Let's go ahead and check out 5. Predict when there will be 80,000 100-year-old Americans. How can we use the equation to help us with that one? Yes? Yes, okay, so notice how the y values are represented in thousands. So you should be plugging in a 1,000 number. This is 80,000. So we're going to plug in 80 for that y value. Okay, and then you can have the rest of your equation. So how might you want to solve this one? First of all, can we maybe take a guess as to what the time might be? If you look at your data table. Ashlyn, you're shaking your head. What do you think? Say it again? Maybe 7. Okay, so notice how 80 is in between 75 and 94. So the time would be somewhere in between 2000 and 2002, which means our x number should possibly be between 6 and 8. Okay, maybe 7. Maybe it will get a decimal answer, like we're halfway or a quarter way through a year. Okay, but at least we can approximate or have a rough idea about where what our answer should be. Okay, so how might you want to go ahead and solve that? Good, Hannah? Let's graph it, right. Perfect. We have multiple x's. Okay, so we're going to let the calculator do the work for us. We already have the one equation in our calculator, right? So let's just go ahead and type in the other side of 80. And go ahead and hit graph. Where are we looking at to find our x solution? Good, Marie? The intersection point. All right, so second calc, option 5. Move the spider to where you think it is. And then almost done. Good, Sarah? Enter 3 times. 1, 2, 3. All right, so 6.457. That's in between the two numbers we thought, right? Between 6 and 8. So what's this telling us? When were there 80,000 100-year-old Americans? Can you take a guess as to when the year was? Go, Marie? Halfway through 2000, right. So exactly 6 represents the very beginning of 2000, like January 1st. If we have 6.457, we're about halfway through that year. So we can say about halfway through 2000. Even though the answer is 6.457, we have to relate it back to the problem. What does that actually mean? What does that tell us? We doing okay? All right. What I want you to do for the rest of the class, which is about 20 minutes, okay? I want you to try some of the homework problems, either from the last section or this one, and start getting used to the calculator. Okay, I'll be walking around if you need any help. Deal?